Along the freezing Baltic coastline of Poland, a canal less than 1.5 kilometers long sparked years of controversy across Europe. That canal is Vistula Spit Canal. At first glance, it appears to be just a waterway connecting Vistula Lagoon with Dansk Bay. But what Poland truly wanted to create was an escape from decades of geopolitical dependence. Before Vistula Spit Canal existed, every vessel entering the port of Elbląg from the Baltic Sea had to pass through the Baltic Strait, which is controlled by Russia. That meant Poland's access route to the Baltic Sea was effectively dependent on Russia. To change that reality, Poland decided to spend $450 million to cut through a nearly 70-kilometer-long Baltic sand spit and create an entirely new route to the sea. In today's video, join Mandrin Tech as we explore how a tiny canal became one of the most symbolic geopolitical infrastructure projects in modern Europe. Vistula Spit Canal is located in the Nowy Świat area in northern Poland, cutting through the narrow strip of land that separates Vistula Lagoon from Dansk Bay on the Baltic Sea. The structure is approximately 1.3 kilometers long, more than 120 meters wide, and about 5 meters deep, allowing medium-sized vessels to travel directly from the sea into the lagoon without passing through the Baltic Strait in Russian territory. The project began construction in 2019 by the Besix and NDI Construction Consortium, opened its first phase in 2022, and continued completing infrastructure works in the following years. In addition to the main canal, the entire system also includes a 270-meter-long lock with 4 gates weighing approximately 160 tons each, 2 breakwaters, a movable bridge, and a modern maritime control center. However, the greatest value of the Vistula Spit Canal does not lie in its engineering scale or shipping capacity. For Poland, it is also a strategic project that allows the country, for the first time, to fully control access to and from the Vistula Lagoon without depending on a maritime route controlled by Russia in the Baltic region. The excavation of the Vistula Spit Canal was considered the most important and complex phase of the entire project. The construction site was located on a coastal sand spit with weak geology, highly vulnerable to erosion, and constantly exposed to waves from the Baltic Sea, making construction especially difficult. To open the canal route through this sand barrier, contractors deployed dozens of large hydraulic excavators operating continuously along the site. Layers of sand, mud, and sediment were excavated and transported by heavy dump trucks to nearby coastal areas. Instead of being discarded, this material was later reused as foundation fill for artificial islands and the breakwater system that would be constructed in later phases. At the same time, engineers had to implement multiple shoreline stabilization measures to prevent sea waves from eroding the construction site. Hundreds of steel piles were driven deep into the sandy ground along both sides of the excavation route to reinforce the terrain and reduce the impact of water flow throughout the construction process. Next, ground stabilization, using the deep vibro-compaction method, was considered a critical engineering step to ensure the long-term stability of the entire structure. After all soil and rock materials were removed, the slopes were reinforced with geotechnical mesh and covered with a layer of saline soil to help reduce erosion. The excavation and ground stabilization phase alone lasted for many months, turning the area into one of the most complex coastal construction megasites in Poland at that time. After the canal route gradually began to take shape, the focus of the construction site shifted to building the breakwater system protecting the canal entrance on the Baltic Sea. These breakwaters served as the protective barrier that would allow the route to survive long-term in the harsh marine environment. Construction began with the formation of the breakwater core using sand and fill materials recycled from the earlier canal excavation phase. Thousands of tons of material were continuously transported to the sea entrance to create the initial foundation for the breakwater system. Once the breakwater core had been formed, workers continued driving large numbers of steel piles deep into the coastal sandy ground in order to precisely define the alignment and shape of the entire breakwater system. These steel piles also acted as a temporary reinforcement framework, helping stabilize the structure against strong Baltic Sea waves and currents. Next, concrete and reinforcement structures were poured and installed along the steel sheet pile line to secure the shape of the breakwater and increase the load-bearing capacity of the entire structure. Thanks to the steel framework combined with concrete reinforcement, the breakwater could maintain long-term stability against constant wave pressure. This was followed by the dredging and stabilization of the underwater foundation in order to create a stable base capable of supporting the entire breakwater system at the canal entrance. Afterward, massive concrete blocks were installed on the outer side to reinforce the structure. These components were designed with hollow gaps and openings in the middle to reduce the pressure of waves and water currents directly impacting the breakwater, thereby increasing the long-term stability of the entire canal entrance. At the same time as the breakwater construction, the excess sand continued to be used to form an artificial island near the canal entrance area. Initially, the island was only a circular sand formation, approximately 5 kilometers wide in the middle of open water. Over time, however, it was gradually expanded with additional layers of soil, rock, and fill materials transported from the construction site, before eventually becoming a new ecological habitat for coastal birds to nest and live. Once the canal excavation and breakwater system were largely completed, construction of the lock system, the most important structure of the entire project, began. First, in order to create a dry construction area, workers installed parallel double-layer steel and concrete walls surrounding the future lock location. Between the two wall layers, additional reinforcement was added using a system of heavy steel diagonal anchor braces, helping stabilize the foundation throughout the construction process. At both ends of the lock, massive steel gates weighing hundreds of tons were installed and operated by a hydraulic system capable of completely sealing the chamber in order to raise and lower water levels as vessels pass through. Inside the structure, groundwater regulation pipes and automatic valves helped maintain stable water flow without creating turbulence. The entire process was managed through a network of sensors and an electronic control center. Thanks to the application of modern engineering technology, the Vistula Spit lock operates with high precision, withstands major water level differences and harsh climatic conditions, and became the engineering heart of the entire canal system. Finally, the various construction components gradually began to merge into a fully integrated operational system. Alongside the completion of the navigation channel and the stabilization of the entire canal, the surrounding road network was also brought into synchronized completion. The system includes 2 swing bridges crossing the canal, each capable of rotating 90 degrees around a central pivot point. Whenever a vessel prepares to pass through the Vistula Spit Canal, the automated control system activates and the bridges rotate sideways one after another, creating enough clearance for ships to move safely through the canal before returning to their original positions so road traffic can continue flowing normally. Given the relatively narrow geography of the Vistula Spit, integrating swing bridges into the overall operational system was considered an efficient engineering solution, helping optimize space while minimizing traffic disruption between the two sides of the canal. Thanks to the combination of maritime infrastructure, automated mechanical systems, and a synchronized transportation network, the Vistula Spit Canal gradually transformed from a complex coastal construction site into a modern transportation complex capable of operating reliably over the long term in the harsh Baltic environment. The Vistula Spit Canal is not only a maritime infrastructure project, but also carries major strategic significance for Poland in terms of sovereignty, security, and geopolitical influence in the Baltic Sea region. First, the canal allows Poland to regain full control over access to and from the Vistula Lagoon, eliminating its previous dependence on the Baltic Strait controlled by Russia. This carries not only economic importance, but also symbolizes the country's maritime independence and strategic autonomy. In terms of security and defense, the canal enables Polish patrol and logistics vessels to move directly between the lagoon system and the Baltic Sea without passing through Russian waters. As tensions between NATO and Russia continue to rise, the project has become a new strategic connection point in the Baltic region. Meanwhile, Russia strongly opposed the project, arguing that the canal could be used by NATO for military purposes and could affect security in the Baltic Sea. Several European institutions also called for additional reviews regarding environmental impact and regional security concerns, which prolonged the approval process. However, Poland consistently maintained that the canal was a civilian project intended to restore maritime independence and support regional economic development. In addition, the project has helped restore the role of the port city of Elbląg, while encouraging investment in logistics, tourism, and infrastructure across northern Poland. At the same time, it clearly reflects Poland's ambition to strengthen its maritime position and reduce geopolitical dependence through technology, infrastructure, and national self-reliance. Compared to other famous canals around the world, the Vistula Spit Canal is clearly not the largest or the busiest. However, what makes it unique lies in its strategic significance and national symbolism. In Egypt, the Suez Canal is one of the most important maritime routes in the world, connecting the Mediterranean Sea with the Red Sea and allowing ships to travel directly between Europe and Asia without sailing around the Cape of Good Hope. Opened in 1869, the canal stretches for more than 190 kilometers and now handles nearly 12% of global trade traffic, with tens of thousands of vessels passing through each year. Beyond its enormous economic value, Egypt's nationalization of the Suez Canal in 1956 also became a symbol of the country's effort to regain control of strategic infrastructure from foreign influence. Meanwhile, the Panama Canal serves as a bridge connecting the Atlantic Ocean and the Pacific Ocean. Completed in 1914, this canal, stretching approximately 82 kilometers, allows ships to avoid sailing around the southern tip of South America, shortening international maritime routes by thousands of kilometers. Panama's system of 3 massive lock complexes enables vessels to be lifted across an elevation difference of more than 26 meters between the oceans and inland lakes. After more than a decade of cutting through mountains and jungle, moving hundreds of millions of cubic meters of earth and rock, building gigantic lock systems, and paying the price with the lives of tens of thousands of workers, the Panama Canal officially opened. This became one of the most expensive and ambitious engineering projects in the Americas, with a total cost equivalent to more than $10 billion today. And from that moment on, this waterway permanently reshaped global trade. Following the expansion completed in 2016, the canal became capable of accommodating ships with capacities of up to approximately 170,000 deadweight tons, continuing to maintain its role as one of the world's most strategically important shipping routes. But the greatest difference of the Vistula Spit Canal does not lie in its length, shipping volume, or commercial scale. For Poland, the project carries a far more significant geopolitical meaning. It is not simply a new waterway, but a statement that Poland can create its own independent access to the sea without relying on any maritime route controlled by another country. Although only 1 kilometer long, the Vistula Spit Canal has still become one of the most strategically significant infrastructure projects in the Baltic region in recent years. Behind the layers of concrete and steel lies a broader story about the effort to assert national sovereignty amid growing regional tensions. The Vistula Spit Canal is not only an engineering achievement, but also a symbol of self-reliance, where a small nation dared to cut through its own land to create an independent route to the world. What do you think about whether the Vistula Spit Canal was truly a necessary strategic move for Poland? Leave your thoughts in the comments below. And if you want to continue exploring mega infrastructure projects and the engineering works quietly reshaping the modern world map, don't forget to like and subscribe to Mandarin Tech so you won't miss the next videos.